We're going to start looking at that floor plate based system because the panel based system one is really not all that different than what we've done before. So if we miss it, that's not a big deal. I think you can figure it out. But to just summarize that, it's just a point based system. You just need to find another point and then move it off, and you create this little triangle thing. We've done some similar things. Hopefully we'll get a chance to do it. But the floor plate based system is a little bit different. In the sense that now we're actually developing geometry that is specific to an old piece of data. So think of it this way, right? We created a bunch of surfaces that we used in order to create these subdivisions. So we can use those subdivision curves in order to create louvers. And we just do a whole series of offsets and extrusions and lofts, and we just regenerate the data in another way. So the way I'm going to do this is, let's go back to what we were working on today, all of this stuff here. Let's grab some of the curves from our loft. Okay? Remember how we had sets of 2 curves for each one? Well, in most cases, those curves are going to be on the same side of the surface for each surface that we've generated. Okay? Hopefully. So the way I'm going to generate this is I'm going to use a list item, and it doesn't really matter which one, but I'll do a slider from 0 to 1. And you may actually need to turn this stuff off to see it. So here is list item 0. And you'll notice that it actually grabs the bottom edge. I don't want the bottom edge because I'm trying to create a louver system and the sun doesn't affect the building at the bottom edge. I actually want the top edge. So I'm going to jump this over to 1, and you'll see that no longer do I have an edge selected at the bottom. That's good. That's good news. All right. So from that, now I have the basis upon which I can develop that whole other section. So to keep things clean, I'm going to group, well, let me just group all this. I'm going to leave these a little bit separate in case I need to reference something else. And then I'm just going to operate here on the top and start working my way over. One of the things that is very, very important about these curves is that they are planar, right? Because it's just a line-like curve from what you read there, right? So they're inherently planar. When we do our offset in order to create a datum line, and so what I'm gonna do here is, if this is my panel, right, and there's like the top edge, that's the bottom, and my glass is in here, I'm actually going to take, right now our top curve lives there. I'm gonna move that top curve to here so that it doesn't conflict with my geometry, and then I'm going to create another one out here, and then I'm going to loft them together and then extrude it down to create thickness. You guys are following? Nothing new, right? You've all seen this before. We're just doing it in a totally different order. So let's verify that our offset is working properly. So let's go to curve utility offset. Okay, plug those curves in. And what you're going to see here is that, well, I mean, what you may see, depending on how your geometry is created, is that it may go up like mine, or it may go out, depending on what the orientation is. So it seems like that curve is actually not following the XY plane. So we need to make it follow the XY plane. So that happens to be here, but I want to caution you on something very carefully, okay? The world XY is not always what you want, because the world XY has a positive and negative direction in the XY direction. So each of these surfaces and each of the curves has its own particular XY orientation, and we need to pay close attention to that. So here's what I'll do in order to get this to function pretty close to the way I want it to work. I need to find the center point, and then I need to find a plane on that center point. and then I need to offset this referential to that plane. Are you guys following so far? Okay. So that's where we're going to plug in that plane. And, well, yeah, you guys can figure it out from there. But so finding that center point is simple enough. I wish there was just a center point function, or I guess you could do a param at 0.5. You could do divide curve and then list item and find the center one. I think what I'll do is I'm trying to find a more clever way of doing this. Perp frames should do it. Let's do a perp frame. No, that one's not parameter based. Analysis. Perp frame, singular. That's what I want. Or horizontal frame. Horizontal frame might actually be better. I'm going to use that. So let's use horizontal frame here. And notice how it says curve to evaluate. And then it says parameter on the curve to evaluate. So this parameter, we need to set where along the curve it's going to be. So let's plug in the curves. And then let's set what the parameter is going to be. I am hoping that it will operate as a percentage. So let's go to 0.5 and plug that in. I don't see them. Whoops. What the? Reparametrize? Okay, we have to reparametrize it. There we go. So make sure that you reparametrize the curve input. I was hoping we wouldn't have to do that and that it would assume that for us, but it did not. So anyway, with this thing reparametrized, we now have a plane in each of those orientations. And if you look at it here in the top view, you should see that each of those planes, where is it? Here, yeah, there we go. So each of those planes is accurately rotating with each of the curves. That's important because when we plug these planes in to be used as our offset orientation, we're now going to see a reorganization here. Well, it doesn't seem to. Why is it still going up? Or was it going up in the first place? Maybe that was just illusion. Yeah, it could have been an illusion. Maybe I don't need to do this, but hey, I did it anyway. Now you know how to do it in case it doesn't go in the right direction. So anyway, so it looks like we have our x direction is going along with the curve. Okay. Then we have the y direction going along. That's where it's offsetting, is along the y direction. So let's change that value. Let's do, actually, sorry, what I want to do is go over here and I want to take this offset value. Okay, because remember, I'm first moving it to the other side of the frame that I created. You guys should understand this concept from the bridge, right? When we did the bridge definition. Referential moves. Yeah. So whether or not you use a wireless connector or you just plug it in doesn't matter to me. But these two are pretty correlated to one another, so I don't mind if you just cross-reference them. So this is our new curve location, and it's pretty subtle. You really shouldn't be able to see a major difference between the two. And it looks like it actually is still going on the wrong side. So I'm going to make it a negative. Go to math, operators, negative. And I'll plug that in here. And then this will go in there. Now it's going to go outward. This is all I've done. Okay, I grabbed the curves that I used to create the base surfaces that I subdivided. Okay, remember we had our extrusions. Okay, then we used bounding box to get our curves at the top and bottom of each one. Or not bounding box, sorry, that's BRIP. Then we used list item in order to get just one of those curves. because each of those slivers or masses has a top and a bottom, and it created two curves that we used to create a surface. I only want the top curve this time. So that's what that did. Then I didn't need this apparently. It looked like it was just a illusion, visual error, but the horizontal frame will help you make sure that your curves are going to always be in the same orientation to offset from that curve. Okay? Zoom in.
Oh, I know it.
Reparametrize maybe?
No, I didn't have the negative. Yeah.
Okay. All right. Let's see how we're doing on time for this video. All right. Well, I'm just going to do one more for you real fast before I close out the video. So we have the curve that exists on the outside of our frame, but now we need the one that's going to create the top face of our louver system. So that's as easy as copying the offset and redefining the values. So if I offset this curve instead, I can create a new numerical value for how far out from the building each of these surfaces is going to go. And so for me, I'm going to say anywhere from 0 to 5 feet, but make sure you put some decimals in there so we have some room to flex. I'll plug that in to D and then just push this curve out. It looks like it still needs to be a negative. So you could recreate the slider or put a negative on, but I'm going to say negative 5.00 to 0. And now I'm going to leave it at 5 feet just so it's really exaggerated. Okay, nothing special so far, really. We're just kind of recycling similar ideas. Yes?
Oh, where did you connect the negative to?
The negative came from the distance of the offset for our frames, our mullion frames. Okay, so final thought, and then I'll make sure you're all caught up. Just to visually get you cued in to what we've done here, I'm going to do a ruled surf between these two. So ruled surface, and I'm just going to plug in one system here to the other system there. And here you can see that we're actually creating louvers that are going to shade our building. Questions? All right, I'll make sure you're caught up before we move on.